training and configuring a router so it has the ability to forward IPv6 packets is pretty cool. I still remember back more than a decade ago when I was configuring IPv6 for the first time. It's like, oh, it's working. I still kind of feel that way because the adoption of IPv6 hasn't been as dramatic as we expected it to be by this point, but still having the skills of how it works, why it works is important to have. So in this nugget, I'd like to introduce you to the topology that you and I get to use as our lab so we can get some hands-on practice, and also talk with you about some link local address and also some global addresses that we'll be using inside of the lab. So without further ado, let's take a close look at our topology. So here's our topology. We'll go from left to right. So we've got Bob, who is acting as our user for this scenario. And we have R1, R2, and R3 in the path between Bob and the server that Bob wants to access. And if we look at these three routers and think, boy, these three routers look pretty similar. They've got interface 0, 0 on the left and 1, 0 on the right on each of them. This looks like the same hardware topology that we used in the static routing for IPv4. And it's true. I thought if we use a common topology that we're already familiar with, we can then up the game and start using IPv6 instead of IPv4 and have a great experience in both understanding and also configuring and verifying static routes with IPv6 on this topology. So let me bring you into the fold as far as what the plan is for IPv6. This is the network, or the first 64 bits that we're going to be using on our networks. 2001, DB8, 6783, and then X. Now, we might look at that X and say, wait, Keith, these are hexadecimal characters. So what we're going to do is we're going to use that X as a placeholder to represent individual networks in our topology. And here's what I mean by that. With this X right here, over here, this is going to be a 1. So this is going to be the network 2001 DB8 6783 1 with the 64-bit mask. This number here, this 12, represents the network between R1 and R2. So this network segment is 2001 DB8 6783 12, and so forth. Then between R2 and R3, we have 23. So I wanted to give you a heads up on what the plan was there and what the IP addressing for IPv6 is going to be, so it's very, very clear. And that way, there's no mystery. So if we see 12, just think, oh, that's the network between R1 and R2. Or if we see network 23 in this position here, that's the network between R2 and R3. And over here on the client, we're going to use the host address of :10. So that's going to be Bob's PC, and the server is over here at :200. Now, also behind the scenes, let me clear that off. Also behind the scenes, IPv6 is using link local addresses as well. And whenever possible, I don't like to leave too much to chance as far as having them auto-assign their link local addresses. So I thought what I'd like to do also for each of these is use a link local address of FE80 : Y, where Y equals the router number. So on R1's interfaces, the link local address is going to be FE80 : 1 on both interfaces. And R2, it's going to be FE80 : 2 on both interfaces. And R3, FE80 : 3 on both interfaces. And we'll just hard code that as part of our configuration so we know exactly what the link local addresses are. And while we're at it also, for these three routers with our IPv6, the host portion is going to match the router number. So for this interface on R1, it would be 2001 DB8 6783 1 for that network, : 1 for the host portion on R1 on this interface. And then over here on this interface on R1, it would be 2001 DB8 6783 12 : 1. So effectively, the link local address and the global address that we're going to use on the router interfaces are going to end with the number associated with that router. And from a learning perspective, because these IPv6 addresses, there's a lot of digits involved, that makes it a little bit cleaner and easier as we're working with, okay, what static route do we need, or how do we put this in place? It's half the battle when we understand and are clear on what the plan is for our IP addresses. So moving forward, this is the plan we're going to use, and I'll put this topology up on DCNUG in the lab. So when you're using MPuTTY and you're connecting to R1, R2, and R3, we can also, on that administration PC, we can also bring up this topology just to verify the IP addresses that we are going to plan on using. So here's our plan of attack. In the next video, we're going to take this lab that we just looked at, and we are going to configure all the interfaces, the 00 and 10 interfaces, with link local addresses based on our plan, with the IPv6 global addresses based on our plan, because that is what's going to bring in directly connected routes into each of the routers. And so once they each have directly connected routes to their two networks respectively, we can then go ahead as we proceed forward with static routes and start adding the new static routes. Network-based static routes, default static routes, and also host-based static routes, all for IPv6. So without further ado, I'll see you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.